Okay, I think I'm live. Somebody tell me if the audio works or not. Hopefully somebody's here.
It's hard to believe that Mint Mobile can be good. It just...
Cool. Oh, good. Okay. Audio seems to work. So, just gonna wait a minute and then I will start doing stuff. Oh, I'm gonna need power. Okay, 1 second. Sound is doubled. Yes, it is. I know why. Okay, it should be better now. I hope. Alright, well, I'm gonna get into it. My screen is very far away from over here, so I'll just check back occasionally to see if something else is broken. So first thing, I guess, more coil winding. Where is my first one? So here's the goal. That is like 2100 turns. So I gotta make 3 more. Luckily, Mr. Stepper Motor here is gonna help. So I've just got this hooked up to one of my OSR control boards, and it's just running a pretty basic script where I just tell it in serial how many turns I want, and then it spins. Zero control of speed or anything, so hopefully it's still okay. I don't remember which way it spins, so we'll figure that out. And then, yeah, so I need to get some tape. And I think that should be it. Oh, I got tape. Okay. My sound is no longer doubled. Hooray. I should have thought this through better. I put the comments like the furthest away from as possible for me. All right. Power, cool. USB would be good. Okay. Oh, the googly eyes. Yeah, you're right. I have to do googly eyes. All right. Hold everything. So many cables. Okay, we have just a few choices of sizes here. I'm thinking somewhat small ones. These might be a little big. I wanted to like put them on top of those bolts on the coupler. Where's all the small ones? There we go. Okay. What? Hey, I got picked by the algorithm, sort of. My last video did alright. I'm not complaining. Alright, I'm gonna super glue my fingers together, so if I suddenly disappear, that's why. Oh, perfect. Alright. By the way, for any new people, this is actually engineering stuff. Yeah, it's not arts and crafts. I promise. Uh-oh, this one was a little bigger. That's all right. Well, it's special, and that's what matters. Okay, just setting up the spool now because it's very janky. So the spool is gonna live on this, which is just a little Allen key that I crammed into some 80/20. And then put you down for a sec. Oh, come on. All right. Okay, spool is all set up. Very robust. So, why googly eyes? I'm not sure. I think I made a joke, or somebody mentioned googly eyes in the Discord, and I said okay. And I've been putting googly eyes on most projects. I kind of forgot on the last few, but that's all right. Nobody noticed. Some people might have noticed. All right, and now we'll secure this guy down because it will try to move. Yeah, this should be fine. We'll see. Failure is more exciting anyway. All right, so I'm just gonna test this out to see if it actually works still or not, and to see which direction it goes. Okay, it does still work. And I thought I wanted it to go the other way. Oh, that's loose. Okay. All right, I'm gonna change the direction of this because I want to. This is the wrong script. I don't remember what I called it or where it lives, so I'm gonna go with it. All right, so it's going this way. Got my wire. Give it a decent tail. And just going to start it by hand for a few turns to make sure that it doesn't totally explode when it starts spinning. All right, and then I have my little guide stick, and I will readjust the camera so you get a better view. Yep, I am winding coils. Sorry, I don't know what I'm doing, so I should probably explain stuff somewhat often as people join. So yeah, we are winding coils. So we have the goal, which is 2000 turn electromagnet. And I got a little coil winder that I rigged up. So we're just gonna run this, and I'll give you the full view. And I'm gonna send it for 100 turns first to make sure everything works, and then go for way more. Oh, that looks good. It's gonna be a complete mess by the time I get like 2 more layers up, so don't get your hopes up. I'm impressed I got it good for this long, honestly. Yeah, it's falling apart. Oh no. All right, going for 500 more. It's doing its own thing. I tried. Oh, that right side looks so good. Wow. And then the left side is just a mess. It's fine. I genuinely wonder how much that affects the efficiency of this thing. Like, if I could perfectly wind it, like fully machine controlled winding, it's got to be better, but how much better? Yeah, automated feed gate. I wanted to do that, but I honestly didn't even want to build this winding machine until I tried to wind a coil by hand and realized after half an hour and only like 200 turns in that it really sucks. So this was the least amount of effort I can put into it, and yet I still, like, you know, designed these custom spools with this fancy interface because I wanted them to have flat ends for my application, which I guess I should explain that too, because it probably isn't obvious. But the end goal here is to put these coils onto this board. I probably shouldn't blind myself. Which is going to be a magnetic levitation platform, but it's going to be a much smarter one than ones you buy, so it's actually going to have like you know, digital sensing and a microcontroller on it, and it'll allow for some more advanced control stuff, as opposed to the ones in like toys and desk ornaments, which are fully analog and kind of dumb. All right, and we are at 500 out of 2,000. This is taking a lot longer than I realized, so I'll probably just wind like, I'll wind one more coil, and then I'll, well, we'll see. We'll see how much time this takes, because I realize watching the same thing over and over is probably boring, even though this is kind of mesmerizing for me to watch. Wait, how many did I put in? Oh, I already did 100, okay. Yeah, so the count now is... That might be a little small for you guys to see. Can I zoom in on this? Oh, I can! Look at that! Grandpa view. Alright. Hopefully this text is large enough to read. If not, sorry. But yeah, so we're at 600 turns, so... yes, I got a degree. Sorry, let me just start this and then I'll speak words like human. That's fine. Yeah, so I got a degree in computer engineering and currently work as an engineer. I'm an integration engineer, so I do like mostly kind of software scripting, some actual back-end stuff, some calibration, automation. I do a little bit of mechanical design, not really much electrical stuff other than debugging. So that's probably why when I do projects, I like to kind of lean more towards electrical stuff, because I don't get to do that as much in my... Oh, hey! First problem. All right. That was at 700 turns. Yeah, it's for the count. Yeah, stepper motor's for the count, because if it's DC, I have no idea what the count is. All right, darn. This is the exact thing that happened with the last one. So, yeah. All right, super glue it is. So yeah, basically these ends are just glued on to the ferrite cores. So, if there's enough of a force that's like opposing your little spinning, well, it can sometimes break that joint. And that means that it no longer can be driven from this side, but it can still be driven from this side. So I'm going to try to carefully just flip it around, and then I'll have to find this script so I can reverse the direction, because that's why this direction was originally reversed. Oh, goodness. Yeah, no, I love my job. I don't know, I just like engineering, and I'm at like a pretty small company, so I can mostly do my own thing. It's a lot of fun. Coil winder. All right, so we want to reverse the direction, which is, I don't know where I did that, honestly. Set direction, here we go. Using my totally built from scratch motor library, because why not? COM port 4, and this is the OSR V1. Yep, V1. Okay. So this should flip the direction, and then it's just a matter of gluing this coil back together and then flipping it around and hoping it'll still work. So. Let me just and upload successful. All right. All right, so now this thing is going to want to fall apart, because everything I build likes to fall apart. No, it's just because it's broken. Yeah, so here you can kind of see we're Yeah, this end cap just came off. So, should I even bother trying to glue it now? Probably. Yeah, I shouldn't let my problems get worse than they already are. Just gonna back this up a little. So now I gotta be a little careful because it will 100% want to expand because of all those tightly wound coils, and I don't want it to. Oh wow, that actually just ripped off the plastic. Nice. Alright, so I'm just gonna globby globby glob. This is how you fix problems. Okay. And we're gonna let it dry in the jig. And we're going to drive from the other side so that hopefully the other side has a strong enough connection, or at least a slightly stronger connection. And then I will check the chat real quick because I haven't checked that in a minute. Why will I try? Oh, cool. Well, thanks. I'm just doing my thing, but I mean, anybody can do this, honestly. It just takes enough dedication and, time to learn and try and fail and be okay with lots of failure. Like, take right now, for example. I'm failing. And yes, I can recap what I'm doing. So I am winding coils for a electromagnetic levitation platform that I'm building from scratch, which is going to be like a fancy microcontroller version rather than the ones that you buy now, which are like kind of toys, and they're all just fully analog, zero control. So yeah, we got a coil here, and we're just trying to match that. Originally, I wanted to wind all 4 coils, but that is clearly going to take far too long. So we're just going to do this one, and then we're going to move on to testing it, and then some CAD stuff. Yeah, glue fixes everything. Glue is glue. All right, so we are at 700. Oh, okay. So I'm just gonna do 1 and make sure it's now spinning the new correct direction. Huzzah! And we should be good to go. So we are at 700. I'll do another 300, so we're at an even 1,000. And then I guess we'll just go for it and do the last 1,000 or 11. I honestly don't remember how many turns it's supposed to be, but I'll check with a multimeter. And we just got to match the other one. So here goes 300. Click, 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 click. Let me move the mic a little bit away from that annoying thing. So yeah, I'm thinking I will finish winding this 1 coil, assuming it doesn't fall apart again and be too difficult. Then after that, can throw it on the very lev, which is the name of this board. It's not very creative. And then we will have 2 coils. Oh, I'll have to solder a connector onto it. Yeah, that's all right. Soldering's pretty quick. So I'll probably solder on the connector. I'll throw it on the board. I will power it on, make sure it actually does its magnetic thing. You guys will be able to see this thing in operation for the first time. It should be pretty cool. It seems like it's getting quieter right now, which is concerning me a little. Okay, I guess it's fine. Yeah, and then we'll have 2 coils, so we'll be able to test the pretty terrible control loop that currently exists with 2 coils, so it still won't be enough to actually levitate anything. But I can at least kind of feel if, like, say the x-axis has any control. So, like, alright, I'm gonna break it again by blinding myself, but in the center there we have the 3-axis magnetometer, which is basically a super fancy Hall sensor that's not that fancy, but gives you... Oh, cool, we're done. Okay. Going for Burke. Here goes 1,000 more. So yeah, this 3-axis Hall effect magnetometer sensor is going to give me pretty precise... It's going to give me numbers that's going to tell me the magnetic field strength in all 3 axes rather than just like, you know, generic field strength. So I get strength and direction, and I think some tape kind of got into the coils, but that's all right. So anyway, what I'm doing with that is I'm feeding that into my control loop, and I'm going to use that to control position in 3 axes. And that means that I could just set an arbitrary point to have it like hover, you know, maybe... This is going to be pretty powerful, so it should be able to levitate maybe 50 millimeters up above the coils. Whoops, I just went over the edge. Oh well. So yeah, I could give it a fixed set point and just have it levitate, and that's like what all the other ones do, which is pretty cool, but not that cool. So my plan was to use it and have like a pre-programmed routine in it, so I can actually have the magnet move up and down, and then I'm not quite sure how well it's going to work in like the XY plane. I think I'll be able to get it to like either pitch a little or maybe even like shift a little in XY. I'm going to test it out and see what actually happens when I try to change that set point, because I'm not too sure. I feel like if anything, it's just going to kind of rotate it, which is fine by me. What are you gonna levitate? I was thinking about that too. So I feel like it'd be kind of cool to do like a rocket, but rockets are also really tall and they don't have a good place I can put like a big magnet near the bottom because they're such a thin cross section. So I might do like lunar lander or something like that. I might just do a UFO and be kind of lame. I don't know. But the like end goal with this project isn't stopping with this first version. It's going to be to then take 2 or 3 of these like boards, so 2 or 3 of these, and have like a multi, I don't even know what you'd call it, but basically you get something that's got 3 magnets on it in like fixed points that are allowed to kind of have some pitch and wobble and wiggling, and then you can control the height of all 3 of those, and then get some like super precise and potentially interesting control of this thing. So like the goal was to use to put this on like a DeLorean model, and I could have a DeLorean that just kind of flies around, and it's like it's not actually going to fly around, but it'll like, you know, float up, and then you'll be able to like kind of pitch and roll and do all sorts of stuff like that. But we'll see how one works, because this might not work that well, and if that's the case, I'm not going to bother making more of these, because this wire is so expensive. Each one of these coils is 10 bucks in wire alone, which is honestly obnoxious, but that's copper, I guess. I don't know. Alright, this the right side of the coil's gotten pretty messed up. Oh well. And we are at 940, so we have about 300 more winds to go, and then we'll see. So I actually use a custom 3D printer I built myself. It's called the Eclipse 3D2. I used to sell them, don't anymore. But yeah, it's like a Core XY. It's fully enclosed. It's kind of like, I don't really know if there's anything similar to it on the market. There's a bunch of other DIY designs that are kind of a similar Core XY, but I don't know of any commercial ones. I might be a little biased, but I think it's the best printer in the world, so... Okay, we are running a little low on wire. Hopefully we have enough. I did the math, and there should be enough. But it's starting to scare me. And don't worry, this coil winding's almost done. I should have realized how slow this was. Otherwise, I would have started with one that was half done already. No worries, though. Hello. All right, 100 wines to go. We'll check the resistance, and then it might need like 50 more wines. It might be good. We will see. It's getting a little thick though. It's kind of growing outside the outline of the spools. So I'm thinking this one wasn't wound as tight and is probably done. I just hope it's not getting overwound. We'll see. Okay, so knifey. Where's my knife? Knife. All right. So this stuff is enamel coated, so you gotta scrape that off. Ooh, no, annoying. Whatever, I'll fix that if this is done. So just scraping off the enamel so I can probe it with my multimeter. And I'm just gonna pull out the camera a bit. Uh-oh, okay. The camera might shut off from overheating. We'll see. This is my first time doing this, so if that happens, we'll figure it out. Actually, if that happens, I'll just switch over to CAD stuff. So yeah, what I was thinking was after I get this project going a little further and test a few things, and I'm pretty happy with it, I was going to move over to CAD, and then I started the rather ridiculous task of building yet another open source robot arm, because I want to build one to put a camera on, because I think that'd be real cool. Alright, so this is a poor connection. I should just get a lighter and do this properly. There we go, 21.7 ohms. And the other one I have is 22 point something or other, 22.2. So 21.7 to 22.2. So yeah, we'll need I don't know, I'll do 100 more wines and see where that puts us. That might be too many. I'll just do 50. Knife's name is Knifey. You wish. Knife doesn't have a name, because I don't name inanimate objects. Oh, what a mess. Man. This one could have gone a little better, I think. Oh no. Come on. This is the one place it can't be. Alright, oh, there we go, almost. Oh no, camera shut down. Alright, cool. Welp, that's good to know. So we're gonna put that on hold while the camera cools off a little. We'll have to figure out how to handle this for future things. I think I can set it to have a higher overheat setting. But anyway, until then, I'll just leave this up but to the side. That's old. And we can completely pivot. Coil winder's name is Windy McWine Face. Yeah, that is its name, but it's not actually a name. It's just a reference. It can't have a name because it's not alive. And I'm standing by that. All right. So, you ready for this? Oh, actually, well, I need the camera to show the first part of this, but I'll pull this up. All right, let's see if the camera wants to turn back on. Camera? No. Okay. Well, you'll have to use your imagination. So yeah, I don't know why, but last night I was just like, you know what? I'd love to build a robot arm. And yes, there's a ton of open source designs out there, but none of them were made by me, so I want to build one. That's honestly the entire reason. So what I have so far is a harmonic drive unit, which is using I forget what the name is, like the flex spline. I forget. There's an actual name for this. But anyway, it's a little hard to tell what's going on from this. But essentially the number of teeth on this one and this one don't match. This top one has 2 teeth more. Or wait, why does it have? Oh no, it doesn't have the same. Yeah, so, and then there'll be a belt here that's kind of inside out, so teeth facing out, and that belt's going to stretch around these 2 bearings. So as the this input spins, you can see the teeth will line up as the bearing goes past, and then they'll misalign. And you know, the output spins like, I think it's a reduction of 29 to 1. So pretty good. And it's using pretty much all like cheap off-the-shelf parts. It's a HTD5 belt, 608 bearings. The only kind of expensive part is we need a real big bearing here, which this is a 6820, which apparently they're only like $15 on eBay. They must be like really out of spec or terrible or something. But that doesn't really matter for open source robots. So yeah, big bearing there. Have a NEMA 23 that's coming in here, and it's going to connect to the little funny shaped inner piece. Oh, I forgot. Inventor always like defaults to no outline, so it's hard to see stuff. But yeah, NEMA 23 directly inputting to that spinning part in the center, and then yeah, you know, crazy gear down. So it should be pretty good. So this is going to be one part of the base, and then I have where is it? Okay, I'll have to find it. And projects. Yeah, this project is called the OS ARM, because I have the OSR control board. So OS ARM, it's a pirate joke. Here is the actual like mock-up kind of assembly. So I don't know if I'm gonna make it quite this chunky, because that's gonna be a lot of plastic. But the hope is to do like pretty much fully 3D printed, have a decent payload, maybe around 1 kilogram, a pretty good range, 500 millimeter radius. Actually, this is quite a bit further. I might scale that back a little. And then it's going to be 6'd off. So we've got rotational base, first degree, first hinge joint, second hinge joint, a rotation on the wrist, and then a rotation and a pitch here. And then the camera or whatever will be mounted here. And then this whole from here on will be like semi-hot swappable, so I'll be able to put on different tool heads if I ever for some reason have some other use case for this thing. And then yeah, I'm hoping that I can reinforce these parts with steel cables on the inside, so still keep it cheap and still have it be 3D printed, but be pretty strong. And yeah, this is some absurd reach. I mean, I guess I can keep it and just like only go this far, and that'll be a little, make the joints a little happier rather than going straight, but we'll see. I can always make these shorter. So yeah, anyway, the piece that I have now, that goes here. So that'll be on one side, and then the other side is just going to be a much smaller bearing just for support, and then I'll put an encoder on it or something. So yeah, I have been master modeling stuff. So where is it? Oh yeah, the master models for each part. So yeah, this harmonic drive is master modeled. So I have like this fancy sketch, and then I can change anything I want, and it'll just update all the parts dynamically, which is fun. But for this first draft of the full arm, I don't think I'm going to bother master modeling it, because I'm probably going to change so much stuff that it just won't make sense, and it's going to break every time I want to add a feature. So I'm just going to kind of like wing it and see how it does. So with that, I guess we can start with this first joint. So we have something to lost. So we can attach something here. Actually, you know what? First, let's do a little more with this, because I would like to be able to actually test this on its own. And honestly, the first video about this arm is most likely not going to be the full arm, because I actually have other things I need to do in my life besides work on this arm nonstop. So I'm thinking I'll probably have like 1 or 2 joints, and we'll do as much as I can to make this gearbox, the harmonic drive, get it like pretty well tested, figure out what the torque limits are, all that stuff. So first, let's just quickly finish up this piece. So I'm just gonna make sure these are symmetric with whatever arbitrary spacing I feel like going with. Also, I cut in kind of a strange way, I guess, so don't make fun of me. All right. So let's just make all these for M5 bolts. That seems like a decent size. Yeah, I think that'll be all right. This middle one, no, that'll work. Okay. Give these 6 millimeters of clearance all around. And then let's pull this down so it's centered. Okay. And don't want these. So all right, I don't think I want those going that far, so let's go with like 20. And then I can add the nut pocket. Yeah, I'll probably want to fasten these from the bottom, so. I'm just going to add hex nuts. Does anybody happen to know the size of M5 hex nuts offhand? I can look it up, but I don't know. I should remember this one. I'll just look it up. This is the best resource. I don't know which one has it. Here. S5. 8. Okay. That sounds about right. So, give these 8.2, accounting for FDMiness. Let's get a better look. And yeah, vertical align all these. Whoa. Uh-oh. What did you do? What is it? What is it constrained by? Nothing. It's constrained by nothing. Okay. I love when I accidentally place constraints without meaning to. What are you constrained by? Okay. You can fix anything by just deleting it. True story. Alright, so these are gonna interfere with those holes a little. Alright, so I'm gonna pull this down to be like 18mm offset, which is fine. I think it's still plenty. And I'm gonna have to add some cuts out to the edge on these. But first things first, let's change this to -18. Let's change this to 18. Yeah, that'll be fine. First prototype. It's not going to be perfect. That's not what I wanted. Okay. Alright, so this one's accessible. These guys are not, so I'll just pull them all out the back. And this guy out the front. And this one out the front. And we've got some... What are these guys doing? Yeah, I need an official quote book. It'd be just filled with nonsense. All right. These are going to be fine. I know my lines were not constrained, but again, first draft. This doesn't matter. Okay. Oh, that little projected line running through cut it. Okay. Well, I think we're good. I should probably figure out how wide M5 nuts are. And that would be 4mm. So make this 4.5. Yeah, and that's good. I'm actually going to make this -16 so I have some space after. And okay. First draft, so I'm allowed to do weird things. Okay. Cool. So we have a way to mount this, which is good. And now let's build quickly a test arm just to make sure we have the mounting pattern right, and then we can build the first arm. So we're going to be building this first link, or at least the first draft of the first link. All right. So we are mounting it to this face, which has, I believe, 12 holes, and they are 40 millimeter diameter. Okay, that's easy. All right, so let's just build a little test load arm. So it's just gonna be a slot, and we need more than 80, so let's say 90. And, ooh, this is, oh, radius. Okay. And how far is this? That'll fit on my print bed, just barely. And then we've got the mounting pattern, which is going to be here, 12, good, done. This is kind of a waste of plastic, so I'm not actually going to do that. I'm just going to, what am I going to do? No, I'll keep you. Pull you around, pull you around. And then yeah, I think that's fine. This, I mean, how much torque is this going to have? Probably a decent amount, so. We'll add a little hole for hanging stuff from. And I don't know, I think that's pretty good. I will constrain this to the center. I will tangentify. Yeah, I'd say this is a pretty good little test arm. Yeah, that's good. All right. And I think it's going to need to have this cut back a little because I'm pretty sure the mating face is set in. Yeah, it is. Not too far. These holes shouldn't have any bolts coming out this side. They're just for attaching the motor plate. So, 1.5 millimeters, so I'll give it like 4. So we'll just cut 4 millimeters in, and then we have our little testy piece, and this is 100 millimeter arm. So, how much is this going to lift? That is the question. I don't know, honestly. I don't have enough weight around here to hang on it, so I'm probably just going to have to like use a digital scale, and oh, I can get one of those little hanging fish hooks and pull on it. That might be what I'll do. But yeah, so the main thing I'm going to want to test with this is total torque carrying capacity, and then more importantly than that is backlash. So total torque will at least tell me how heavy or how light my arm has to be for it to not completely fail. And then, is this first draft? Yeah, I guess this is first draft. And then backlash is more important because backlash is going to be super annoying. I do plan on putting encoders. Where is it? Here it is. So I plan on putting encoders at each joint at the like actual driving interface rather than the motor side. So I should be able to see all the backlash, but still I don't really want to be compensating for all of it all the time because that's just real annoying. Okay, so we got the arm, the little test weight arm. I'd say that's good to go. me just throw it in here just to make sure. Might as well. Okay, and it will be concentric. No. Okay. Yeah, that should be fine. So it's just gonna sit off to the side and just lift. Good. All right. I wonder if my camera's cooled enough. Let me see if it has, so that we can finish up over here. So one moment. Let me also see if I can find that temperature setting real quick. Darn. I don't see the temperature setting. So we're just gonna have to go until it overheats again. All right, so let's see if we can get this back up. Well, thank you, Aiden. Yeah, that's, well, clearly my most popular video yet, so I'm gonna try to figure out why that is, and then hopefully keep it going. All right, so let's get back to fixing this mess. So camera's pretty cool, so we should have at least like 20 minutes before it cuts out again. All right, so we were about half an ohm short, so we needed like another 50 coils, but this got all tangled up. So I just gotta try to pull it back, which looks easy. I wish it was easy. All right. I'm just gonna give it a ton of slack. Man. At this point, it might have been easier to just wind it by hand. Okay. Cool. Okay, I got it all off of the motor shaft, which is the important part, because that would mean I can't actually take this off if I couldn't. So there's going to be quite a few kind of dangling coils. Oh well. All right. We're good. Okay. So let's get back to this. So windy McWind face. Let's give it another 50 winds and see if that's enough. So send in at 50. Oh no. I'm just gonna pull it off and finish by hand. It's only 50 more. Alright. Man, what a bummer. This is why I don't like hacking things together to make my life easier, because it never makes my life easier. Okay. Well, this is where we're at. So close. And this is all the over-spooled parts that are just gonna live out there. So let's get some more glue. Oh, I could put them back in. Hey, this was intentional. All right, please stay there. Can't open the glue. Okay. Lots and lots of glue. All right, I think we saved it. That actually worked out pretty well. Fortunately, I have extra thick glue, and the cure time is 10 to 30 seconds, which means it's not actually like strong for a minute or two. So I'm just gonna have to keep squeezing it pretty tight and attempt to give it. I don't know how I'm gonna wind this by hand at this point. All right. You know what, honestly, it's only like half an ohm off. That's, I don't know. Somebody do the power math. It's not like that bad, right? I can definitely calibrate it out. It's just going to be annoying that one coil is less powerful than the others, but like, let's be honest, what are the chances that I'll be able to wind all the other two coils without incident? Pretty low. So I'm just going to give this like a minute or two of winding, and then wherever we're at, we're at. And it will be good enough. I would also highly recommend nobody does this ever. Just buy electromagnets, don't wind your own. All right, good enough, good enough. All right, now I need to keep tension on that somehow. Tape, where's the tape? Tape, uh-oh, okay, there it is. All right, let me find the Kapton. Here it is. And this was so much easier when it was actually still able to be wound on the machine when I did the other one, because I was able to get this on pretty tight. But something smells like it's burning. I know what that is. That's the reason that I built a V2 of the OSR control board, because V1 used a linear regulator to step down my supply voltage to 5 volts. So for some reason I was just like, you know what, that's fine. Let me cut this. I mean, it is fine. It just gets really hot. And when you're operating a control board with 4 stepper drives on it, you don't really want to be adding extra heat. Like, that's typically not the best idea. So for V2, I changed to a switching regulator. Way more efficient. It was just more work to do. All right, coil is done. Let me just get the lighter to properly burn off the enamel so that it's going to be a little easier to solder. Alrighty. What else am I forgetting? Probably a lot. All right, place your bets. How long until the camera overheats again? I'm giving it like 10 more minutes, if even. Okay. So resistance check, the target, as a reminder, mostly to myself, the reference coil is 22.4. This new one is, it was 21 something before, so hopefully we broke 22. Okay. I don't trust that. That's way too jumpy. I think these are still a little dirty. Well, it's in the right neighborhood. And that's what counts. $23? Okay. Somewhere around there. I didn't think I had that many turns, but that will do. So, let's say goodbye to this control board and see how hot it is. Oh yeah, oh that's toasty. Yeah, okay. This guy's done. The winder is done for now. That's powered off. Oh, this board's so warm. Okay. Cool, cool. Let's... You know what? Let me show you where I'm at with one before I solder on the second one, because odds are this camera's going to die before I can even get to that. So... let me hook up USB and eventually power. And I will throw this on coil 1, why not? And I've got my big old magnet here. Which, as it turns out, might not actually be big enough. From what I could tell, for the size of my electromagnets, I would probably want a magnet like 2 or 3 times bigger than that. I was just kind of scared to buy one that big. Okay. No idea if you guys can read the numbers, but currently it's not actually powered in like DC power, it's just USB power, so it's running the microcontroller. There's these like XPOW, that whole line, that's part of the control loop, which currently is not really doing anything, which is okay because the Z power is too low. Yeah. But ignoring that, the line below it, that's just the raw magnetometer settings. So we've got, this is going to change the X value significantly. This will change Y. and then Z is, of course, height. So the original plan was to have them kind of, the coils on top here, and then have this magnet be floating up above. But as you can tell, the Z power, not Z pow, the Z reading of the magnetometer up here is only like 1 tick, which I don't know the conversion to Teslas, but it's pretty weak. I don't think it'll be strong enough to actually get a good reading up here. So the alternative is to either mount the coils on the bottom or just flip this whole thing over. Leaning towards this because there's a ground plane on the bottom, and I would like to not mess with the field too much, like reading this magnet. I don't care if it distorts the field coming out of the coils, but I want to get a good reading where this magnet is. But when I do this, then I'm reading the same height above the coils, and I'm reading like 12, 13. So this should just give me a lot better resolution and hopefully not break everything. So we can power it on, but because of how the control loop works, it's actually, no, we can get it to, if we do it this way, we can get it to power on the electromagnet. So these coils were wound with 12 volts as the target voltage. Can run them on more. They'll just overheat. Although, because of how this whole thing's set up, I can just like limit the output power, so I could really run this on any voltage as long as the firmware is adjusted accordingly. And it's already making a little whine. No cheese. Yeah, and that's it. It's floating it. it's hard to tell. Ugh. I mean, it's not hard to tell that it's magnetic, but yeah, it's powered on. It's floating it. It's giving it. This is in slot 1, which is Y positive. So the furthest right variable, that is what it's actually sending this coil. Yeah, so it's giving it 80 out of 255, so it's only at like a third power right now. It's pretty cool. I haven't tried this yet, so yeah, right now it's at 0 power. So as it comes down, the magnetometer is going to pick up the field, and then it's going to power it up. And it should reach a steady state somewhere. Like if I... Yeah, it's kind of hard to tell with just one. But it works. Cool. Just put that there for safekeeping. Yeah, what now? Let me break out the soldering gear and can finish up the second coil, and then I can throw it in slot 3. And if all goes well, I should be able to get it to kind of like at least control this one axis, and actually probably the height as well, as long as I can strain it in this direction. And yeah, let's see what that does. So yeah. This board's also using my newer, actual using a switching regulator for 5 volts and linear for 3, so it also stays pretty cool. Really cool, actually. It doesn't get hot at all, which is nice. Iron, which gotta give Aiden on Discord and Patreon a huge shout out. He made a insane. Oh, we're good. Nothing fell. Maybe Maybe I should plug this in before I talk and distract myself. Yeah. Yeah, again, Aiden, really appreciate the donation. Helping me get a better iron. My, like $20 Amazon special was really, really causing issues. All right, power on. Power on. Plug in. Okay, now it's powering on. And we have solder. We have a connector. We have fumes. We have a window open. All right, this is chunky. I'm gonna try to trim this a little better. Yeah, that'll work. Okay. And coil, this one. Oh, okay, overheat warning's coming up again, so time is limited. I should put my Peltier glass chiller on this thing. That would definitely help. Alright. And auto temp shut down. Cool. Okay. One moment. I'm going to try to find this temperature shutdown setting because this is pretty annoying. And I know the setting exists. And it won't let me because it's too hot. All right. Well, what can we do here? So we're just going to give that like 1 minute to cool down so I can check the settings and hopefully change that so that it doesn't keep overheating. But until then, if you want to look at my code, ooh, how exciting. Yeah, so still very much a work in progress, but the gist of it is VeryLev has like all the important stuff where you can update the current target and the current variable from sensors, which is getting pulled in this main loop. So whatever I have running in here is just going to kind of feed it consistently changing mag targets, and then it's going to keep updating it with the current magnets, and then there's a few PID loops. So this is like the kind of, I don't know how well this is going to work. We're going to find out. But yeah, so there's a PID loop for the X, Y, and Z. And each time it calls these, each time it actually, is generating the coil output. So we only have 4 coils to control 3 axes. So there's some overlap there. So it basically uses the X and the Y as like ratios of power for those 2 coils, and then uses the Z to set the overall power of the 4. So it'll like figure out the arbitrary relative powers between the 4 coils for X and Y, and then the Z will just apply a scalar to it. Yeah, I'm not very experienced with dealing with magnetic field stuff, so that's probably going to lead to some weird control issues, and it's going to make it like oscillate and be hard to control. But we'll see. All right, let's see if this camera is gonna allow me to check the settings without shutting down. Huzzah! Okay. And let me look up where that setting is. Oh, this is exciting. Yes. Menu setup, auto power off temp. Standard high. Yes. Okay, I think we're all set. Let's go back to live view. And okay, we should be good. So hopefully this won't shut down again. I think it'll be all right now. Let me move this mic because that's far away. All right, so goal here, so we're just going to be soldering up this little connector to the newly wound coil, and then we can go ahead and plug it in and test out one axis, maybe two axes of the control loop. We will see how it does. Okay, that's why it was hard to get a resistance reading. There's still a lot of enamel on there. Where's that lighter? Yep, there you go. Okay. And wire does get hot. Key. And clean that off. Oh, sorry. Okay, much better. That's nice exposed copper. So let's actually figure out what this resistance is, because I'm kind of curious. Here. Okay, that makes more sense. 22.7. I'm pretty sure that was what it was before I hand wound a few, but that's fine. Lower resistance is more power anyway, so nobody is going to argue with that. All right, so let me just trim down the exposed part to be a little less. And soldering iron's on. All right. Now the annoying part is soldering without one of those little helping hands things, which I'm realizing now I solder enough that I should probably just buy one. I used to have one, but it fell apart, and I refused to replace it. Let's just tin that. Come on. Stick. It's doing a little. Oh, yeah, I turned this up for soldering a ground plane. Let's go back down. Okay. And let's tin these, which are the easier ones. Okay. And now, will it stick? That one's bad. Okay. Does not want to stick to this one. Yeah, this is what I get. All right. Flux helps. Oh, I do have flux. I mean, this has supposed flux, but it's like the cheapest solder I could find on Amazon, so that's not helping. There we go. Woof. Not touching after I clean it. Well, that's no fun. Let's try to do the trickier one first. Is that bridged? Not anymore. That's pretty good. Okay. Happy with that one. And this guy should be pretty easy. Okay. Yeah, great. Good. Done. All right. So we have 2 coils. Let me just make sure that it is not shorted, because that would be a very bad day. It also wouldn't be the first time that I powered on something that was shorted that I should have checked. Yep, it's good. All right, so let's go with the most likely actual layout. So this will be 1 and 3. One of these may, or yeah, only, we'll see. I might have to flip one if the polarity's wrong. Use my helping hand. Yeah, I know, I will. Not sure if you were here before, but I had one and it broke. And they always seem to break because the hands are just like cheap crimps. So I was protesting it by torturing myself. All right, and let me fix the view a little. There you go. Focus over there. And it doesn't seem to be overheating, so I think that setting is working. Power. It's buzzing, not blowing up. Good. That's repelling. That's repelling. That's good. Let me make this bigger. I'm also gonna reset it. I'm pretty sure I have a memory leak somewhere, because it really bogs down after a little. Which one was I using? Not this one. Yeah, much faster now. Okay. So, it's sensing it. Cool. Ooh. Ooh. I mean, oh, why is it oh, maybe the coils are a little too far apart. Yeah, I think that was it. Oh no! Ooh, what is that? Ooh, okay, I don't know what I just did, but that light is the 3.3 volts power indicator, so that's not supposed to blink. Okay. Oh no. That's weird. What did it even short? Okay, well that's probably going to be the end of this. Most likely I'll just have to build up another board, which is annoying, but not the end of the world. Well, quick check before I totally give up hope. So these should not be connected. These should not be connected. These shouldn't be. I forget which ones are ground. That would have helped, probably. I don't know. Okay, well this is ground. Oh, goodness. Why are, let's see what those are supposed to do. Unplugging coils while you're testing. Yeah, well. I probably should have. Okay, so these are supposed to be ground. Oh, these are supposed to be 3 volts. So, for some reason, the 3v3 line appears to have gotten pulled to ground just a little. Yeah, 11 ohms, and that's the same one, so it should be 11. Yeah. So 11 ohms to ground. Maybe I just like busted a component, but no, I probably shorted something bad. Well, I'll have to look a little closer at it. Maybe I can save it. Maybe not. Either way, that was fun. Alright, so I think I'm going to wrap up this live stream while I debug my board and wallow in sorrow. Yeah, we'll see. Hopefully it's an easy fix. Like, I don't know. This board's not all that complicated. Yeah, so I was just checking these two contacts. Ground and 3v3, they're not supposed to have a low resistance between them, but they do now after dropping it. The magnet landed in here, flipped, and it landed on this coil, as magnets do. And like, what could it have shorted? I don't really know. Like I do have these pads exposed, but that, just in case I had to like tap into it, I wanted to make it easier. Not realizing the magnet was not magnetic, conductive, and would just bridge stuff. But like, all I can think of is maybe, no, I don't even think I could have hit the 5 volts on the USB, because that's kind of covered by the connector. Oh, I probably hit the 12 volts here, and maybe connected that to something. We'll see. Maybe it just squished a component too and shorted it. Well, I will post updates in the Discord, so if any of you aren't in the Discord yet and you want to figure out what went wrong, that is where it will be announced. Yeah, so I think that's pretty much it. So thank you guys for watching. Appreciate it. Not sure if I'm going to keep streaming or not in the future. Still don't really know what my like end goal is with YouTube. I definitely will keep doing monthly project videos. As far as stuff in between, I don't know. I tried this. It was okay. We'll see if I want to do another or not. I probably am not going to do like mid-project updates, at least not every 2 weeks. That's just a lot of editing. And I would prefer to actually work on projects, which is why I wanted to do streaming as a way to work on projects while also creating some content that people can engage with. But I don't know. We'll see. So let me know what you guys thought. Yeah, and if you're not in the Discord, definitely join the Discord. Lots of stuff happening in there. And it's definitely not a cult, so there's that. Yeah, so that's pretty much it. Thank you all. See ya.